Hi, this is BK Ahiri. Today's presentation is on chi-square test. It's absolutely in introduction part. Under this part, we will going to cover basic concepts, definition, types of chi-square test. Then we will follow assumptions, chi-square distribution, formula, and steps for computation. Lastly, we will going to follow applications and limitations. Before going into the detailed discussion of it, I would like to offer an example. These examples will help you to make a clear sense on chi-square test. In this example, the items in a time management scale can be responded through 5 response categories. The distribution of responses to the 7th number item as responded by 100 participants is mentioned below. Do these responses diverge significantly from the distribution to be expected if there are no preferences in the group? See, overall there are 100 participants. Here you need to follow that how many variables are there. There is only one variable, that is the response of this 100 participants. What is the nature of the variable? You need to identify it out. See, here the variable is categorical, and these categories are 5: strongly approve, approve, indifferent, disapprove, strongly disapprove. And the overall data is a frequency. Now, in the next example, here a recent study reported that 500 college students were chosen and questioned in each of 4 different countries. One of the questions related to whether these students often attended international seminars on their preferred topics. The following data resulted. In the country, there are 4 country names given. Number of attending seminars: 48, 36, 51, 55. Based on this data, is it plausible that the proportion of college students who often attended international seminars are the same for these countries? So here again, your task is to identify how many variables are over there and what is the nature of the variable. In the next example, a university administrator wants to know if there is a difference in the proportion of students who go on to graduate school across different majors. Use the data below to test whether there is a relation between college major and going to grad school. See how many variables are there. There are 2 variables. One is the graduate school and another one is the major subject. Both are categorical in nature. Why? Because graduate school is a variable which is divided into 2 levels, that is yes and no. Major subject is a variable which is divided into 3 categories. One is the psychology, economics and sociology. So these are actually in categories, these 2 variables. Here one more thing is that these underlined lines are very much important to understand chi-square test. There is a relation between college major and going to grad school. Seeing that relation word, don't think that it is correlation, because yes, it only denotes whether the 2 variables are related, associated or not, but it cannot give you the magnitude or direction of relationship. So chi-square, it's not correlation. If you go any book regarding chi-square test, you will see that these 2 lines are very much important. And in each and every book, you will get these 2 lines. First line is chi-square test involves checking if observed frequencies in one or more categories match expected frequencies. That to estimate null hypothesis true or false. Here in the first line, see, observed frequency and expected frequency. These two are the terminology for this. Observed frequency is the applicational part. That means you are collecting data from your sample, and after collecting data, you are presenting it in terms of frequencies, and these frequencies are known as the observed frequencies. But if you say what is expected frequency is the theoretical one. While you're going to compute chi-square for your examination purpose or for your classwork or your home practices, you will see this expected frequency can be mentioned over there in the sums, but they can also not be mentioned into the sums. If it is not mentioned, you need to calculate them out. Why? Because chi-square is a test which actually deals with the frequencies, and it used to measure a difference, how much observed frequency is different from the theoretical or expected frequency. So this is very important in chi-square to understand, and based on the differences you have to draw your conclusion that whether your null hypothesis is true or not. So you are drawing your conclusion regarding the null hypothesis. That means you are working over here with the inferential statistics. So chi-square is an inferential statistics also. In the second line, it also tries to estimate whether two variables are associated or not. Here I have already mentioned that instead of association, relation or independence, these two words also can come. It is saying associated or not, but it is not correlation. There exists a significant, these two statistics is different. Correlation is different statistics, chi-square is different statistics. Chi-square only tell you that whether two variables are associated or not, whether two variables are related or not, whether two variables are independent or not, but it will not tell you anything about the measures, direction of association, about the causal information. Now these are the basic concepts which help you to understand to generate an overall idea about the chi-square. First one is chi-square is a Greek letter denoted by the symbol chi, and chi-square is often denoted by chi-square. So see the symbol over here. Many of the times I found students used to do a mistake that instead of writing a curvy x, they used to write something straight away x. But straight lines, using straight lines while you write the symbol of chi-square, it is error. It is wrong. You need to give a curvy x for this. It was developed by Carl Pearson in 1900. It is pronounced as chi. Now see, here in some books you will get the C-A-R-L, Carl Pearson, and in other books you will get K-A-R-L, Carl Pearson. Which is true? Actually both are true. The thing is that Carl Pearson was so much influenced by Karl Marx, and to show the honor to Karl Marx, he has changed his name from C-A-R-L, Carl, to K-A-R-L, Carl. Now in the next point, it is a type of non-parametric statistics. So from here you can idealize that whatever the assumptions non-parametric statistics should need to follow, chi-square follows all those assumptions and criteria. Guilford in 1956 called it general purpose statistics. Why? Because it has its wider application. That's why Guilford recommended it as general purpose statistics. It is an inferential statistics that I already told. We used to draw inferences using this type of statistics. It is a hypothesis testing method. So while researcher going to compute chi-square, beforehand he used to mention the hypothesis. and with the help of chi-square computation, they can derive the decision. They can go with the part that whether null hypothesis is true or not. It is an analysis of frequencies. We have seen chi-square test very much deals with observed frequencies and the expected frequencies. Then next point, it only follows chi-square distribution. So in my next slides, I will discuss what is chi-square distribution. But before that, try to remember that while we are computing chi-square test, the scores are distributed following the chi-square distribution, because we do have a general thing in our mind that we always go with the normal distribution. Chi-square test do not need to follow normal distribution. It used to follow chi-square distribution. In the next point, it finds the significance of deviation of an experimentally observed frequency distribution from a proposed frequency distribution. So experimentally observed frequency distribution, it is generally represented in the formula. When we discuss the formula, it generally follows FO symbol, and the proposed frequency distribution, this is the FE symbol as it is represented in the formula. This proposed part is the theoretical one and experimentally observed frequency is the practical one. It can be computed through more intuitive available statistical software packages like SPSS, Stata, SAS. It can be run in Google Sheets and Microsoft Excel also. The aim of chi-square test is to understand the frequency distribution of a single categorical variable or find a relation between two categorical variables. From this point, we have a clear sense that chi-square may involve one variable or it may include two variables, but whatever the variables it is including, it should be categorical in nature. There are two definitions. The first definition is the chi-square test represents a usual method of comparing experimentally obtained results from those to be expected theoretically on some hypothesis. See, this definition is given by Garrett and Woodworth in 1981. And the thing is that it is again representing the same thing as we have already discussed, that chi-square test is a difference between the expected and obtained frequencies. This particular thing is more technically represented in the second definition, which is actually given by Aaron and Cooks in 2007. And when you're going to compute chi-square test, this second definition will give you the computational detail. See, chi-square is the sum overall the categories of the square difference between the observed and expected frequencies divided by expected frequency. So you need to, from this second definition, we have a clear sense of the steps of computation, and that denotes that we need to make a difference between observed and expected frequencies and divided them by the expected frequency. Then we need to square them up, and after squaring them, we need to sum up them. So this we will discuss in detail later on. Here I have represented the types of chi-square test. See, the thing is that 3 chi-square tests have been mentioned, 2 in this particular slide and 1 in the next slide. But still, I would like to mention that in my next video, I will discuss on the types in detailed manner. So over here, I have given a brief presentation, because in my next video, I will going to discuss how to compute chi-square along with the types. So first type, test for goodness of fit. The chi-square goodness of fit test checks whether your sample data is likely to be from a specific theoretical distribution. The test gives us a way to decide if the data values have a good enough fit to our idea, or if our idea is questionable. It generally includes one group. Next one is the testing independence. Here what happens? It estimates whether two variables are associated or not. Generally used to unrelated groups, and it is used in two ways, like for testing the null hypothesis of independence to denote the two given variables are independent of each other, and second is computing the value of contingency coefficient, a measurement of relationship existing between the two variables. The thing is that in my next video, I will discuss what is contingency and table and how it is calculated. Here you need to remember that a chi-square test of independence, or you can say it as a chi-square test of association also, it only estimates whether or not two variables are significantly independent to each other. That is the main issue over here, what you need to remember. It can, but remember that the thing that it can neither measure the magnitude and the direction of association, nor predict a cause and effect relationship between the variables. These are two important things which you need to remember in this particular part. And for the test for goodness of fit, the expected values are computed here on the basis of the proposed theoretical distribution. And in such cases, the frequency observed distribution, whether it is differing with the proposed distribution significantly or not, that is the main thing need to be covered. This is the third type of chi-square test for comparing variance, and it is obviously a non-parametric statistics. It is generally used to determine whether the variance of a variable obtained from a particular sample has the same size as the known population variance of the same variables. In order to determine the population variance, it is very much necessary to examine the entire population. And you know, it is little bit difficult for our psychological researchers. It is often sufficient to obtain the population variance based on a representative sample. When conducting the chi-square test, the variable being tested can have any level on a scale. But here also few points need to be more clear for your understanding, and we will go with it, this part, in my next videos. Here are some assumptions which we use to fulfill for chi-square test. Now see, for computing every statistics, we need to fulfill the assumptions. If the assumptions are not get fulfilled, we cannot able to go for that particular statistics. That is what we need to remember. So in the first assumption, we will see the data should be in frequencies. That is very much clear to us, because chi-square test is a test for analyzing frequencies, and from the beginning we are dealing with the frequencies. We have already covered what is observed frequencies, what is expected frequencies. Next assumption is there can be one or two variables in chi-square test, but remember, whatever the number, it may be one or two, but the variables should be categorical in nature, and it should be either in nominal or ordinal level of measurement. See, if your data is in interval scale also, you can change your data into the ordinal level of measurement, and then you can compute chi-square test. Chi-square test is applicable for discrete, nominal and ordinal variables. So what is discrete variable? Discrete variable is one that has a specific value and cannot have values between these specific values. Suppose I am asking you how many times you have attended to your doctor in last 6 months, and you can reply like one time or two time or three time or not at all. So your number may be like 0, 1, 2, 3 in that way. But here, while you are responding, your number must not come in that way. 1.26 times, ma'am, or 2.13 times, ma'am. So that is the characteristics of a discrete variable, which will give you whole number. In between, there shouldn't be any number. Next assumption, the categories or levels of the mentioned variables are mutually exclusive in nature. So suppose you are considering one participant in a particular cell while computing the chi-square, you cannot take her score for another cell also, because they are the categories or levels of the variables are mutually exclusive. See the last assumption, the study groups must be independent. So that is again very much important point to remember over here. It requires no assumption for normal distribution, that we already discussed about it. It does not require homogeneity of variances. So if we have two groups of individuals for chi-square test, both the groups need not to be equivalent group. It does not require any pre-computed statistics for its computation. That is again very much important because it's a non-parametric statistics. It is even very useful for a very small sample size. Now we are going to discuss on chi-square distribution. So going into that part, I would like to say something like while Carl Pearson was started to thinking about the statistics, he found two things. One is at that very time, so many biological researches were happening, and he identified that all the researchers were assuming that data is normally distributed, but he can idealize the fact, he can understand that fact, not always the data used to be normally distributed. So there is something we need to search for where the data is not normally distributed. Second one is, he has seen that not every phenomena in our reality, not every phenomena is in causality. So there are much more things which are contingent. So idealizing these 2 points, that there is something which is deviated from normal distribution and there is something which is contingent, he has thought about chi-square test. See over here, chi-square distribution is a continuous distribution with specific k degrees of freedom. So according to the degrees of freedom, we will see the exact shape of chi-square distribution get varied. And that we are going to discuss in our later slides. It is used to describe the distribution of a sum of squared random variables. It is also used to test the goodness of fit of a distribution of the data, whether the data series are independent, and for estimating confidences surrounding variance and squared deviation for a random variable from a normal distribution. It's a special case of gamma distribution. The last two lines are very important. It is generally skewed to the right because chi-square statistics cannot be less than 0. Why it cannot be less than 0? Because we are saying chi-square, we are squaring it out. So it is not going to be less than 0. But the upper limit, there is no limit to how large it can be. Now, this is the slide where I have represented how the exact shape of the chi-square distribution depends on the degrees of freedom. See the red line, it's the distribution of chi-square when df equals to 1. But it changes when df equals to 2 from in the brown line. See the third, df equals to 3 in the dark blue line, how the distribution again changed, and it is very marked in each and every time. It is changing very markedly, And gradually when we going into the df equals to 10 part, that is the light blue distribution over here, see, it is generally as if approaches towards a normal distribution. Chi-square itself does not need to fulfill the normal distribution criteria. It is a non-parametric statistics, but it can approaches towards normal distribution. Here is the basic formula for the chi-square test. The calculation for chi-square test combine information from observed frequency O and expected frequency E for each level of categorical variable. For each cell category, researchers find the difference between the observed and expected values, square them and divide by the expected values. The sum of this value across cells for the test statistic, this is shown in the formula below. So chi-square itself is a ratio. Here I need to mention that when you are giving symbol of chi-square, don't write such kind of x, because straight lines with x square does not represent chi-square. Just try to give a curvy x to represent the symbol of chi-square. Here again I have given some formula. Both are the same formula, but if you go with the books, several authors use different type of presentation. So in this two type of way, you can get the formula. So here O is the observed frequency, where over here it is FO. Here E is the expected frequencies. Here it is written as FE. See here the summation signs are in both purposes same. So what is the fundamental idea of it? It is observed value minus expected values whole square divided by expected value. Now the steps for computing chi-square test. Here, while you are going to compute chi-square test, you need to find, as a researcher, first you need to define the null and alternative hypothesis. Then you need to identify the alpha level, whether it is 0.05 or 0.01. Then you need to check the data for errors, then whether the assumptions for the test are getting fulfilled or not. Being a student, when you are going to compute it in your class or in your home practices or in the examination hall, you need to write null and alternative hypothesis, but you don't need to decide the alpha value, data errors, or checking the assumptions part. Yes, checking the assumption part is important to identify whether the sum is chi-square or not. But separately, if you computing it out in your examination purpose, you don't need to write over them. It is very important. Perform the test and draw your conclusion. Determine the actual observed frequencies in each category, because determination of actual observed frequency and expected frequency is very important, because chi-square itself the analysis of frequencies. So you need to determine them, and the steps need to be followed, like subtract observed and expected frequencies, then square the differences, then divide each square differences by the expected frequencies for its category. After that, you need to add up the results of questions for all the categories. Finally, the theoretical value depends on both the alpha value and the degrees of freedom for your data. What is the theoretical value here? The critical value is the theoretical value. And see, when you are going to check the chi-square table, you can identify it out that the critical value gets changed on the basis of the degrees of freedom and the alpha level. So you need to remember this part. Now the application one. It's a non-parametric test used for frequency analysis where the measurement variables is a category. It is clear to all of us. Data can be in proportion or percentage. If we are computing chi-square, data can be in proportion or percentage. It makes use of chi-square distribution. Chi-square test can be used in goodness of fit of observation. It helps to estimate how closely an observed distribution matches an expected theoretical distribution on hypotheses like hypothesis of chance, hypothesis of equal probability, and hypothesis of normal distribution. I hope this part will be more clear to you when in my next videos I will going to discuss regarding the types and its calculations. Under application, it's a test of independence of attributes. It tests whether two individual variables are independent in a binary manner, yes or no format. It is also applied in testing relationship in two ways. Firstly, testing the null hypothesis of independence to denote the two given variables are independent of each other. Secondly, computing the value of contingency coefficient, a measurement of relationship existing between the two variables. It is also used as a equal probability hypothesis to estimate the probability of having the frequencies in all the given categories as equal. It is used to check the significance of several statistics like phi coefficient, coefficient of concordance, and coefficient of contingency. There are two limitations I have mentioned over here. Researchers, through the result of chi-square, are unable to say which response category is greater or lesser than the other because the chi-square value gives a holistic idea whether it is significant or not. But particularly category-wise, it cannot able to give you any idea. If the categorical variables represent pre-test and post-test observation, then chi-square test of independence is not appropriate. Why not? Because if your observation consider pre-test and post-test, that indicates your independence of observation criteria is getting violated. Because in pre-test and post-test, both person scores are there. So in both set of data, the same person score presents. So the independence of observation is getting violated. So in that case, we need to go for McNemar's test. Now I have mentioned over here a table for chi-square test that will again help you to identify how degrees of freedom and the alpha value both are important. These are the alpha values, right? And here the vertical line represents the degrees of freedom and this horizontal line represents the alpha values. So how these two values are important to identify the chi-square value? Because here see, if you going for this one 0.01 level of significance while the DF is 1, it is 6.635. And if you go for the 0.01 level with DF2, it will be 9.210. So the theoretical value gets changed based on the degrees of freedom, though the alpha value remains same. And if you see, the alpha value get varies in same degrees of freedom. Like while degrees of freedom is 1, under this 0.05 level represents the theoretical value 3.841. And while degrees of freedom is 1, the 0.0501 level of significance will get the critical value 6.635. So it varies on the basis of the both degrees of freedom and critical value. That has already been discussed in my initial discussion. Here I have given some exercises. The first one is what is chi-square test? What conditions are needed to compute chi-square test? You will have the idea from the assumption part. Write the formula for chi-square test and define it. Remember, whenever you are writing the formula, you need to define it out. This is very important. Next question is what is expected and observed frequency. These are very important to identify because you are dealing with chi-square, and chi-square itself is the analysis of frequencies. So you need to know what is the expected frequency, what is observed frequency. Observed frequency is the applied practical value which you get hand in hand. Expected is the theoretical value. Next question is what is the chi-square distribution? What is its shape? Very important question. Now here the question is find the chi-square value at 0.01 level when df equals to 5, 10 and 30. Then the next question is chi-square, find the chi-square value at 0.05 level of significance when the df is 9, 18 and 38. You can take the help of the table, chi-square table, because no one can remember the theoretical value. Here I have given an example, an exercise again, a sum. You can ask me that why ma'am you have given a sum, because in this presentation there is no computation. But still, those who can compute use the sum. But still I have given it, there is some reason. First, let me go with the question. An ice cream company wants to know if people order the same number of different toppings. They look at how many chocolate, strawberry and pineapple ice creams were ordered in the last week. Fill out the rest of the frequency table and test our difference. But my focus in this question is why you consider the sum as chi-square. Give reasons behind your answer. This particular thing help you to make a clear understanding about the chi-square test. That's why this question is here. Thank you.